Okay, so we're going to work some problems here. We covered tangents of circles yesterday, and you've gone over your homework, so now we're going to do some problems on the next page, which is page 2. A lot of these I'm going to set up for you, but I'm not going to completely finish. You can do the rest of the calculations. So what do we know? We know from circle C, there's two tangents, px and py, and they meet at this point P, which is an external point. And we learned that if you have an external point and you have two tangent lines coming from that external point, the distance from that point to the point of tangency are equal. We also see that HJ is 18. That's really the diameter of this circle. So if this is 18, then each of the radiuses have to be 9. Then it also says that PC, this distance right here, all the way is 41. So if PC is 41 and CJ is 9, then this distance here has to be 41 minus 9, or 32. So now I see, I'm trying to figure out, the question asks, what is PX and what is PY? So if I start with PX, I know I can form a right triangle here, and so I can use that right triangle to calculate what is PX. So here's the distance PX. I'm going to call that X. The radius on this side is 9, and the distance from here, from C to P, I know in total is 41. So now, using Pythagorean theorem, you should be able to solve for x. And that's going to give you px. Well, we know px and py are equal, so once you find this, you should be able to find py. And next it asks us for the distance from C to x. Well, if it told you the distance, the whole diameter, hj, was 18, then radius is half a diameter, or 18 divided by 2. So each of the radius, no matter what direction you go, is going to be 9. So C to X has to be 9, and C to Y has to be 9. So that sets up the first problem. You should be able to solve it the rest of the way yourself. Okay? Let's look at the second problem. I'm just going to switch papers here. We talked about a problem like this yesterday. And here we have, this is similar to our gear problem. And so we're going to start up with BC is a common tangential point to circle C and circle D. We're told that BD is 3 and CE is 15. And that DE, this entire distance here, is 30. So now we can use what we learned yesterday about the right angles, and we have a parallel line here, okay, and we can calculate this. If this is a rectangle, then this side is also 3, so this side must be 15 minus 3, or 12. So now I have a right triangle here. Okay, and I'm looking at, if this is 30, this is 3. If this is 15 as a radius, this is 15. So this first step, I can really find xy by saying xy has to equal 30 minus this portion, 3, minus this portion, 15. So that should give us your xy. Now, if I'm trying to find BC, I'm going to move my right triangle that I started, because I saw that I could get to xy without the right triangle. But here, if I draw my right triangle, I have this side being 12, and this side being 30. So using Pythagorean theorem, I could find x, and that basically is your point BC, because it will be parallel to BC and equal. Remember, opposite sides of a rectangle or BC. So this is D. We're really pointing to this part here, which I'll call F. And the point is that BC will be equal to whatever you find for DF. Okay? In this next one, we're looking at number 3. I have a right triangle, right angle, okay? Here, those points of tangency. AB is 5, CD is 15, BE is 12. So I'm going to give you a hint here. You're setting up a proportion to find BD because these two triangles are similar. So 5 is 15 as x is, or 12 plus x is to, back up, I'm sorry. What I want to say as 12 is, this piece here, is to the whole thing 12 plus x. So you should be able to solve that for x, and then you would know the length of BD, and I think from there you should be able to find the length of EC and the length of FG. Okay, I'm going to leave that for you to do. Lastly, I'm going to let you guys look at these problems on your own. Remember, we worked a problem similar to this. You should be able to follow it around. A hint here, you want to find the perimeter of this triangle, 8 plus 10 plus 6, which is going to give you a perimeter of 24. And using the perimeter, you should be able to find x if you define each of these sides in terms of x. So for example, when we look at this side, we're going to be looking at this as portion here as 8 minus x. This portion here is 8 minus x. This portion here as 6 minus x, and so forth and so on, all the way around. And then using our perimeter knowledge of 24 to solve it. So those are some good hints. Remember, you're only going to work 1 through 5.